Hello, good evening everyone. My name is Vishwadeep and I welcome you all on Unacademy's Computer Science Channel for unlimited learning. How are you all? कैसे हैं आप सब लोग? All good, all fine or not? Today in this particular lecture, we are going to discuss about floating point representation. This is another topic which has been asked less time, but yes, a good quality type of questions has been asked. So many students are having problems. Sir, what is Mentisa? What is exponent? What is the normalization? If we do normalization every time or not? And there are so many other small questions students are having. So in two sessions, today and tomorrow, we are going to discuss about floating point representation and how the numbers are represented in these representations. About those we are going to discuss. But before we start, let's try to have few more information for you. Information is my introduction and other. Okay, so before we will start, let me introduce myself for all those who don't know about me. My name is Vishwadeep, scored 19 rank in 2010 for my final year. In my final year, before this I have written GATE exam in computer science also in the third year also, and then 682 was the rank. Around after that, I have written GATE exam more 119, 440 I have scored. This is the thing which I went for my masters. IISc Bangalore, I went for my masters. Then I completed MTech from BITS Pillani recently in the data science. And then you can see a rich experience of teaching, and then these are the courses I am teaching on Unacademy's platform. Apart from this, I have taken operating system and compiler design also. Okay, and then if you are here for learning, then we have a great opportunity for you to learn is this. Look at this on Unacademy's platform. If you will go to unacademy.com or Unacademy's learner app, then search my profile Vishwadeep. Once you search my profile Vishwadeep, and then once you follow my profile over there, you'll be getting some special classes. क्या मिलेगा आपको वहां पे? स्पेशल क्लासेस. व्हाट इज दिस स्पेशल क्लासेस? स्पेशल क्लासेस आर फ्री क्लासेस which we conduct on Unacademy's platform. So you go there and learn from those special classes. Those special classes you can attend live, yes. For free, yes. You can listen in the recorded mode also, yes. So whatever previously taken special classes we are having, all those classes you can listen live, recorded also. So you go to the profile and learn from there. So many good sessions I have recorded over there. One more good news is there for you guys, and that good news is this कि I have brought a particular test series for you all. I have brought a test series for you all that is for free. जी हाँ, free है. अभी उसका लिंक अभी मेरे पास है नहीं, but definitely you can find it on the Unacademy's platform. एक free test series आपके लिए start की है हम लोगों ने for free. All the courses will be there, yes, and full length test will be there. Full length test means subject wise 30 question 90-minute test will be there. Okay, so you just go and search on Unacademy's platform under my profile. You will be getting that particular test series also. Okay, so if you will be going for that particular test series, already one test has been done. Next test is on the 2nd October, Friday, 7 p.m. Computer Organization and Architecture. You can write that test for free and you can test your assessment that how well you are doing in your preparation. If you want to learn for betterment of your understanding, for your actual problem solving improvement, then this is the place, Unacademy Plus. And what Unacademy Plus offers you? Live classes, which you can of course listen in recorded mode also. So till the very first day of Unacademy Plus, till the now, whatever the classes have been conducted on Unacademy Plus, all those classes are available for you to learn. आप सारी classes अभी recording mode में सुन सकते हैं any day any time on Unacademy Plus if you take the subscription of Unacademy Plus. Structured schedule will be there, so you will be learning in a closed environment, and hence your learning will be always in the efficient mode. Plus test series will be there, plus unlimited practice will be there, plus so many doubt sessions will be there, so that you don't carry any doubt in the further classes at all. Plus, you will be getting such kind of a closed environment of the sincere students that you will always be motivated to learn. And this particular subscription we are having last day of today. That particular subscription you can get into what in the less prices today, just because the prices are going to be increased maybe from tomorrow or day after tomorrow. पैसे बढ़ जाएंगे. If you want subscription now, only you take, and that subscription you can take using the code VDeep10. If you use the code VDeep10, you will be getting 10% discount, plus you will be getting, if you will be getting this key, you will be getting my mentorship, you will be getting my team ka support, and lots of other benefits you will be getting. And if you want to go for personalized plan for yourself, if you want to go for a personal coach, if you want that you need a personal coach from Unacademy's side, if you want that somebody will personalize your plan, will personalize your solution, your notes, will personalize your planning of study, and you want the studies guidance day by day or week by week, then all these come under another subscription, which is Iconic subscription. This Iconic subscription has all the benefits of plus extra benefit of Iconic subscription, and this subscription also you can get into discounted mode, which will be available आफ्टर यूजिंग दिस कोड VDeep10. अगर आप कोड यूज करते हो तो ही डिस्काउंट मिलेगा, प्लस तो ही आपको मेरा मेंटरशिप मिलेगा, एंड देन ओनली यू विल बी गेटिंग माय टीम का सपोर्ट. एंड टीम, मैं बार बार टीम के बारे में बात कर रहा हूं. दिस इज द टीम विश्वदीप. माय नेम इज विश्वदीप. आई एम देयर इन द टीम. मलेशम सर इज देयर इन द टीम. सतीश यादव सर, खलील सर, पंकज सर. There are so many good faculties, educators. This particular team will take care of your entire GATE preparation. All the courses will be completed. All the courses will be completed up to the maximum depth with maximum number of questions to be practiced, and you can join Unacademy Plus with minimum cost today only, just because tomorrow onwards, maybe tomorrow onwards the prices are going to be increased. तो आप लोग आज ही सब्सक्रिप्शन लें अगर आप चाहते हैं सब्सक्रिप्शन लेना तो. If not, no problem. Okay, so here we have studied a lot. बहुत कुछ आपने पढ़ लिया है. नाउ वी आर गोइंग टू स्टडी अ न्यू टॉपिक टुडे, विच इज फ्लोटिंग पॉइंट रिप्रेजेंटेशन. सो इफ यू आर रेडी, जस्ट लेट मी नो इन द कमेंट बॉक्स यू आर रेडी और नॉट, सो दैट वी कैन गो फर्दर. हम जाएंगे आगे, पढ़ेंगे काफी कुछ. Let's see if you are ready or not. If you are ready, type down in the comment box so that we can start the session. So in the recap, what recap? Yeah, I have covered almost entire subject. We have started with the basics of the computer organization and architecture, and then after that I have gone for instructions, and in the instruction chapter I have gone for addressing modes. Then I have covered the CPU ka design. In that I have covered ALU, data path. Then after that I have covered the control unit and everything. Then I have gone for next chapter, which was IO organization. In the IO organization, so many things I have taught, and including interrupt DM and everything. Then after that we have taken the largest chapter, memory organization. पूरा पढ़ाया मैंने. Every lecture is present in this particular series, memory organization. In that I have taught about cache, mapping, and lots of questions we have solved. After that I started pipeline processing. Pipeline processing I have finished last day, yesterday only, along with non-linear pipelining. अगर non-linear pipelining आपको नहीं पता, you can study from the last class. कल आपको मिल जाएगा कल के lecture में. After that, today we are going to start floating point representation. पहला question है कि why we need floating point representation. I will tell you, don't worry, मैं बताऊंगा आपको कि क्यों जरूरी है floating point representation. First of all, if I will ask you, if you are having a fixed point number, you are having a फिक्स्ड पॉइंट नंबर. अब ये क्या है? अरे जो आपने सीखा है ना नंबर सिस्टम में, दैट इज फिक्स्ड पॉइंट नंबर. वॉट एवर यू हैव लर्नड इन द नंबर सिस्टम, दैट इज द फिक्स्ड पॉइंट नंबर. If suppose you have a fixed point number of suppose 14 or 16 bits, let's say 16 bits. Using 16 bits, what is the maximum range of number you can represent? कितना रेंज का नंबर रिप्रेजेंट कर सकते हो आप, बताओ जल्दी से। हाउ मच रेंज ऑफ नंबर्स यू कैन रिप्रेजेंट? द मैक्सिमम रेंज ऑफ नंबर्स यू कैन रिप्रेजेंट इज -2 power 15 माइनस 2 power 15 टू प्लस का 2 power 15 - 1. This is the range. 32,000 something plus and minus also 32,000 something you can represent using 16-bit ka fixed point number. Suppose I want a larger range than this. If suppose I'll have to store a number which is 50,000. Can I store a number 50,000 in fixed point number in this 16-bit ka register? No. I cannot store 50,000 value. Why? Just because इसका एक fixed range है and range is having maximum value what? 32,000 something. I cannot store 50,000. Yes, that's a big problem, and the problem is the range is very limited. Range is very limited. So scientists have thought that let's have a number representation in such a way that we can have a large range of the numbers using these 16 bits itself. कि क्या हम कोई ऐसा रिप्रेजेंटेशन ला सकते हैं जिसमें कि ये 16 बिट्स की हेल्प से वी कैन हैव अ लार्जर रेंज than this one? Yes, if we could have this, then if we could have had this one, then we were going for this representation, floating point representation. तो साइंटिस्ट ने सोचा कि इससे ज्यादा रेंज चाहिए, हाँ, तो फिर कुछ नया लाना पड़ेगा. सो दे हैव ब्रॉट व्हाट? फ्लोटिंग पॉइंट रिप्रेजेंटेशन. यूजिंग दिस पर्टिकुलर 16-bit number only, we can have larger than this range to be represented in the floating point representation. That was the motive of giving the floating point representation, that we wanted to have a what? दिमाग में रखना है, याद रखना है. तुमको, मुझे आता है, तुम्हें याद रखना है. कैसे याद रखोगे? समझो ना. If you understand, you remember. Simple. So because of giving larger range of the numbers, because we wanted a larger range of numbers, we have gone for floating point representation. अब ये देखिए, पहले थ्योरी पार्ट पूरी कवर करूंगा, उसके बाद I'll explain every single thing one by one कि ये क्यों, कैसे, क्या, कहां. So in the floating point representation, whatever the number of bits you use to represent the number, those number of bits will be divided into 3 fields. What those 3 fields are? S is sign bit. Then next few bits will be given for E, which is exponent. And last में है आपके पास M, which is mantissa. अगर किसी का नाम है मेंटिसा तो, या मेंटी किसी का नाम है तो मेंटी के जैसा. फाइन. ओके, नाउ सी व्हाट दिस साइन सेज. साइन सेज इट्स प्लस और माइनस, तो हमेशा सिंगल बिट यूज होगी इसके लिए. फॉर साइन 1 बिट वैल्यू वी आर गोइंग टू कीप. आपको पता है with the single simple number system, you know कि if this sign bit we have stored, यहाँ पे अगर store किया है 0, which means this particular number is representing a positive number, and if this sign bit you have stored as 1, means the number is representing negative number. ये आपको पता है. अगर आपको पता है, well and good, that's good. Now how many bits for exponent, how many bits for mantissa, ये आप पे डिपेंड करता है. आप मतलब, हाँ सर, हम कुछ कैसे डिसाइड कर सकते हैं? अरे, when you will design some floating point representation for your requirement in a computer system, you will decide कि I should keep these many bits in mantissa and these many bits in exponent. We will see some questions. Based on that, I will tell you कि requirement के हिसाब से, based on the requirement, how many bits you should keep in exponent and mantissa. We will decide that. फाइन. चलिए आगे बढ़ते हैं और डिटेल देखते हैं. व्हाट इज द मेंटिसा? मेंटिसा इज अ साइंड. व्हाई? जस्ट बिकॉज ये वाला साइन है इसलिए. नॉर्मलाइज्ड implicitly or explicitly fraction number. So mantissa is a fraction number, but it is normalized. What type of normalized? Implicit or explicit? क्या होता है सर? सर बताएंगे, थोड़ा रुकिए सर. What is exponent? Exponent is stored in biased form. अरे, theoretical part complete करते हैं. I'll tell you these things one by one. What is normalized mantissa and what is biased exponent. One by one, एक के बाद एक करके सब को निपटाएंगे बॉस। रुको तो सही, थोड़ा रुको तो सही। मुझे एक अपने टीचर की बहुत अच्छी बात याद आ गई। हम जब कैसे बीच में क्वेश्चन पूछते थे ना कि सर ये तो नहीं समझ में आया, तो सर बोलते थे पूरा एक्सप्लेन तो करने दे बेटा। वो बोलते थे मैंने इतना बड़ा खरगोश देखा। सर इतना बड़ा खरगोश ही नहीं होता, अरे ये तो हाथ लाने दो यार। Let me explain completely, then you will understand completely. Okay, so what is biased exponent? I'll take a simple example. I'll explain. चलिए ये देखते हैं. Look at this. Suppose you have taken a floating point representation like this, and I am assuming you have used capital E is, let's say, represented by 4 bits. 4 bits से you have represented these exponent bits. तो 4 bit आपने यूज की है, 4 bits you have used for representing exponent. Now you tell me using the 4 bits what is the range of number you can represent. खाली exponent exponent. Okay, so if I am talking about 4 bit का representation in normal general case, then using the 4 bits you can have a range, and that range is what? The range is -8 to प्लस का 7. ये आपको समझ में आएगा. यू नो बेसिक तो नंबर सिस्टम तो आपको पता है, बेसिक नंबर सिस्टम्स तो यू नो. सो रेंज ऑफ द नंबर्स यू कैन हैव इज -8 to 7. दिस बायस्ड एक्सपोनेंट का कंसेप्ट सेज दैट मुझे रेंज माइनस प्लस में नहीं चाहिए, मुझे रेंज सिर्फ प्लस में चाहिए. The biased exponent says that I don't want my range to be in positive and negative both in the signed manner. I want my range to be in only unsigned manner, only in the positive manner. मुझे पूरा रेंज जो है वो पॉजिटिव मैनर में ही चाहिए. So biased exponent says what? I need only unsigned exponent. ये क्यों करते हैं मैं बाद में बताऊंगा. I'll tell you later. Unsigned exponent. अरे थ्रिलर मूवी चल रही है, थ्रिलर मूवी में सारे सस्पेंस अभी थोड़ी खुल जाएंगे. So only unsigned exponent I want to have here using these 4 bits. So what exactly I'm doing is, हमने क्या किया, whatever the range I could have using these 4 bits, this particular range I will try to transform. What I'll try? I will try to transform this range from negative positive or from signed to unsigned. Unsigned means using the 4 bits. Unsigned means using the 4 bits. How many range or what will be the range you can represent only in the unsigned? Unsigned में क्या range मिल जाएगी आप लोगों को? Unsigned में range मिलेगी 0 to 15. सो मेरा सिंपल सा केस है बॉस कि मैंने ये रेंज जो पॉजिटिव नेगेटिव दोनों को स्टोर कर सकती थी उससे सिर्फ और सिर्फ पॉजिटिव में ट्रांसफॉर्म करा लिया. समझ में आएगा सब कुछ. थोड़ा पेशेंस रखो, कीप लिटिल बिट पेशेंस. आई विल एक्सप्लेन यू एवरी सिंगल थिंग. वंस द कंप्लीट टॉपिक इज डन देन आई विल टेल यू कि नाउ यू टेल मी कि यू अंडरस्टूड और नॉट. डेफिनेटली यू विल अंडरस्टैंड एवरी सिंगल थिंग. जस्ट कीप पेशेंस एंड ट्राई टू कॉन्सेंट्रेट. सो व्हाट आई एम टेलिंग यू इज, इफ आई कैन हैव यूजिंग 4 बिट्स का एक्सपोनेंट this range -8 to 7, but I am not going to have my range this one. I am going to transform it to this particular range. If I am going to transform from this range to this range, what exactly I am doing? मैं समझाने की कोशिश करूंगा आप लोग को. अब I am going to explain you now. What exactly I am going is, suppose you have a number. You have a number. In that number, you got original exponent. You got some original exponent, and that original exponent you have got as -8. हो सकता है, yes, नंबर में हो सकता है, but I am saying कि I don't want to store -8 as exponent here. मुझे यहाँ पे नेगेटिव वैल्यू स्टोर ही नहीं करना मेरे को. तो what I will do, I will transform it. I will transform it into the stored exponent. और stored exponent में transform करने के लिए what I will do is, I will store -8 as represented by 0. तो अगर नंबर में -8 आया तो मैंने -8 यहां पे स्टोर नहीं किया, मैंने 0 स्टोर कर दिया। यार मेरी मर्जी है, मैं कुछ भी स्टोर कराऊं। तुम्हारे नंबर में जो है वो है, उसको ट्रांसफॉर्म करा दिया मैंने ट्रांसफॉर्म करा दिया, एनकोड कर दिया। व्हाट एग्जैक्टली आई एम डूइंग इज आई हैव जस्ट ट्रांसफॉर्म्ड माय ओरिजिनल एक्सपोनेंट टू स्टोर्ड एक्सपोनेंट। ओके, सो इफ -8 को मैंने लिखा 0, -7, if comes -7 in the number, I'm not going to store -7, I'm going to store instead 1. If in the number exponent is -6, I am going to store 2 in the place of -6. Similarly, अगर 0 आया ओरिजिनल एक्सपोनेंट में तो I am going to store 0, no, I am going to store 8 instead. And if I am having in the exponent, original exponent of the number 7, then I am going to store 15 instead. So what exactly I am doing? I am representing my original exponent as a small e and capital E as stored exponent, which I can see here. So I am storing what? I am storing capital E. This is my original exponent of the number. Number के exponent में -8 आया, मैंने store 0 कर दिया। क्या किया exactly? I have gone with this कि I want to get capital E जो मुझे store करना है, which I want to store by doing this. जो भी एक्सपोनेंट में नंबर आया उसमें मैंने 8 को ऐड किया और उसको स्टोर करा दिया। उसको क्या स्टोर करा दिया? व्हाई? जस्ट बिकॉज मुझे यहां पे सिर्फ पॉजिटिव वैल्यू स्टोर करानी थी, बिकॉज आई वांटेड टू स्टोर ओनली अनसाइंड वैल्यू हियर। सो व्हाट आई डिड, ओरिजिनल एक्सपोनेंट व्हाटएवर कम्स आई विल ऐड 8 इनटू दैट एंड देन आई विल स्टोर। हमेशा 8 ऐड करना है? नहीं, फॉर दिस एग्जाम्पल ओनली 8। तो हमेशा क्या ऐड करना है? दिस इज फॉर एग्जाम्पल, ऑलवेज व्हाट वी विल हैव टू डू इज वी विल हैव टू ऐड अ वैल्यू बायस। अभी हमने बायस की वैल्यू यहां पे रखी है 8। क्या रखी है? 8। दैट्स व्हाई आई एम एडिंग 8। For some other example, bias can be 16. For other example, bias can be 32. For other example, bias can be 64 also. So different question, different example, I can have any value of bias. अब वो bias कैसे मिलेगा? अरे वो भी बताएंगे, रुको तो सही। So to get the original exponent, from original exponent to the stored exponent, I am doing what? I am adding bias value. अभी देखो यहाँ पे bias क्या था? 8. You know why? Just because capital E represented by 4 bits. If I am asking a question directly without writing anything, आपको दिमाग लगाना है, concentrate करना है, सुनिए। If I am asking you a simple question, exponent is of 5 bits. Exponent represented by 5 bits. What will be the range you can represent? Type करो जल्दी से, मैं भी आंसर करता हूँ। What can be the range you can represent with 5 bits? Range positive negative दोनों। The range can be -16 to +15. -16 to +15. But the range which I will store with 5 bits of exponent will be, in my mind, 0 to 31. 0 to 31. If I want to store 0 to 31, but exponent range can be -16 to 15, what I will do? I will add bias. And what will be the bias? 16 will be the bias. -16 will be stored as 0, -15 will be stored as 1, and so on. कैसे किया? How could I get 16 by 5 bits, or how can I get 8 with 4 bits? It's very simple thing, 2 power 4 minus 1 or 2 power 5 minus 1. So I am writing here a very simple statement that you need to remember. If exponent is represented by k bits, अगर k bits से आपने exponent represent किया, then what will be the value of bias? Can you tell me what is the bias value? Bias will be equal to 2 power k minus 1. क्या ये सही है? Right? Yes. Here this example 4 bits, 2 power 4 minus 1, 2 power 3, 2 power 3 is 8 bias. For 5 bits, 2 power 4, answer is 16. For 6 bits, 2 power 5, 32. ग्रेट सुपर अमेजिंग पीपल, अमेजिंग, बहुत बढ़िया, आप लोग बहुत अच्छे से सीख रहे हैं। दैट्स अमेजिंग, प्रीटी अमेजिंग। सो इफ यू आर क्लियर अबाउट दिस, लेट मी टेल यू वन मोर थिंग। In your number system, might possible you have studied access codes, access 3 code, access 4 code पढ़े। You know what is the meaning of access 3 code? Access 3 code says कि if I'll have to store 0, I will not store 0, instead I will represent it by 0 plus 3. Yes, 1 I will represent by plus 3 4, 2 I'll represent by plus 3 5. Here in this example, can I say this particular stored exponent is access code? Yes, this is access 8 code. उसमें मैंने 8 को ऐड करके और स्टोर किया है। So instead of giving this information in some other way, they may give you key biased exponent is stored in access 8 code or access 32 code or access 64 code like this. So you can understand access 8 code is nothing but bias is 8. Access 32 code means bias is 32. समझ जाओगे? जल्दी से टाइप करो, टाइप डाउन इन द कमेंट बॉक्स इफ यू विल बी एबल टू अंडरस्टैंड दैट पर्टिकुलर थिंग और नॉट। फाइन, ओके, चलिए। सो इफ दैट मच इज क्लियर, यू कुड अंडरस्टैंड द बायस्ड एक्सपोनेंट। अभी मैं आपको थोड़ी देर बाद बनाऊंगा कि ये बायस्ड एक्सपोनेंट को हमने या एक्सपोनेंट को बायस्ड फॉर्म में क्यों स्टोर किया। आई विल टेल यू लेटर कि why exactly we have stored the exponent in biased form. Later I'll tell you when you will actually understand the numbers and all. I'll tell you, definitely I'll tell you. Fine. So till now you understand ki biased exponent in the storage, I will not store the number directly, its exponent directly. I will first add the bias, then I will store it. Let's talk about mantissa now. Now what is the normalized mantissa? पहले बात करते हैं normalization की। There are two types of normalization I told, implicit and explicit. अब कैसे चलेगा देख लिए बताता हूँ। First of all, let's take a simple number 101.11. This is the number in binary number system I have taken. I am talking about only binary just because we will work only on binary. Now this I will have to normalize. Two types of normalizations are there. One is explicit normalization, another one is implicit normalization. क्या है बताते हैं। Fine. Explicit normalization says that कि you convert this number into 0 point something. इसको इस तरीके से रिप्रेजेंट करो कि ये नंबर मिले 0 point something में। You represent this number into 0 point something. कैसे लिखेंगे? I can write it as 0.10111, or maybe I can write it as 0.010111, or in fact I can write it as like this also. और भी बहुत सारी zeros ऐड कर सकता हूँ। But here is the rule. एक rule है, there is a restriction, and restriction says that if you represent this number into 0 point something, then point के बाद after the point immediate first bit should be 1. After the point immediate first bit should be 1. तो क्या हम ये के लिए जाएंगे? नहीं, point के बाद यहाँ पे 0 नहीं आ सकता। For this one, no, I cannot go. So what should I do? I should go for this representation. This is my explicit normalization in which I represent the number into 0 point something, or restriction क्या है? This, after the point the first bit should be 1. Always 1. Now if you shifted the point, तो फिर इसको complete value as it is, ये value बनाने के लिए, to make that value as it is, then what I'll have to do is I'll have to multiply with something in this so that I can get original value like this. I am just representing this into this way for normalization purpose. So converted like this way, what I am doing is a larger value I am converting into smaller value, then I'll have to multiply by a larger value 2 power 3. कैसे किया? अरे एक नंबर सा नॉर्मल सी बात करता हूँ, ये लिखा है 504.6, ये डेसिमल का नंबर है. सपोज इन दिस पर्टिकुलर डेसिमल नंबर आई एम मेकिंग इट एज लाइक दिस 0.506 5046. If I have shifted this point left side, what I will do, I will multiply 10 to the power 3, 1000 का multiply करेंगे इसमें तो ये नंबर मिल जाएगा. यस मिल जाएगा. This is decimal number system, that's why 10 to the power 3. This is binary number system, that is why 2 to the power 3. इतना तो क्लियर है आप लोगों को. गुड अमन, गुड गुड गुड, नाइस 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 नाइस. इफ यू गाइज आर क्लियर अबाउट दिस, देन लुक एट दिस. If you convert this number into this way, this to this is explicitly normalized now. This particular number is explicitly normalized now. From this normalized number, you can get the mantissa. अब ये mantissa क्या है? Mantissa is nothing but number after the point. Number after the point. So I'm writing here the mantissa is nothing but the number after the point. So what is the number after the point I am getting from here? आप बता सकते हैं कैपिटल M क्या मिलेगा यहाँ से? कैपिटल M you will be getting is equal to 10111. And what is this? This is my original exponent which I could get after normalization. Normalization के बाद जो मुझे मिला है ये है मेरा original exponent and that is small e3. Now I am having a simple question. एक छोटा सा प्रश्न पूछे आपसे, छोटा सा, प्लीज प्लीज परमिशन दे दो. एक छोटा सा डाउट है मेरे को कि क्या हम 3 स्टोर करेंगे as it is? Will I store 3 as it is in the memory? No. I am not going to store 3 in the memory. Look at this. इतनी देर से मैं यही तो गीत गा रहा था आपके सामने. I don't store small e original exponent as it is. First I add bias in that and after that I store, right? So from here I need to calculate capital E, which is nothing but small e original exponent plus bias. After that you will be getting what? Original exponent जो कि यहाँ पे ये here it will be stored. Fine. Understood what is explicit normalization? Remember explicit normalization is कि this number will be represented in such a way कि I can write down 0 point something and in that something the very first bit after the point should be always 1 and after the point जो भी number है वो मेरा है mantissa. What is that? Mantissa. Fine. What is implicit normalization? Implicit normalization says that I need to convert this number into 1 point something. किसमें convert करना है? 1 point something. So let's convert this 1 point something. 1.0111 into 2 to the power 2. Now in this one, what is the restriction? Restriction is before the point here, this particular single bit should be there and it should always be 1. So only single bit is allowed before the point and that is 1. यहाँ पे after the point you can have 0, you can have 1, whatever, but before the point you can have only one bit which is 1. Got it? Same thing जो मैंने ऊपर किया exactly same thing I need to do here also. Let's get our value of mantissa. Mantissa is exactly same thing. क्या? Number after the point. What is the number after the point? 0 1 1 1. This is the mantissa. What is the original exponent I am getting? Small e is 2. Do I store 2 as it is? No, I store capital E which is small e plus bias. I hope you guys are clear about these two types of normalization. मुझे लगता है आप लोग इस normalization के लिए clear होंगे. What is explicit normalization? What is implicit normalization? We are talking about regular representations, the conventional representations, and in the conventional representations, this explicit normalization is default one. If nothing is given in the question, then default normalization is explicit. अगर क्वेश्चन में मेंशन है then we will go with that particular thing. Clear? So if any number is given like this way, Can you get all three things? Sign, yes, positive or negative, you can understand from here. After that, you can normalize based on the normalization, yes. After the normalization, you can get mantissa and exponent, yes. You can get capital E also. तो ये नंबर अगर दे रखा है, you can get all these things. Yes. Now I want to give you the value. Value means what? उल्टा अगर दिया है तो what is ulta? Ulta means what? The opposite is given, the reverse is given, then what happens? अगर reverse given है तो क्या करेंगे? अरे हवन करेंगे, हवन करेंगे, हवन करेंगे. Okay, fine. Look at this. This is sine. This is exponent. This is mantissa. I have given some value here in the sign plus or minus 1 0. Some exponent bits I have given. Some mantissa bits I have given. Can you tell me what value it represents? What value it represents? Like this way. This is the value. Can I recover it from this way? Yes, I can do it. So for that, how you can get the value? There is a formula. अब ये formula कोई रटने वाला नहीं है. You don't have to remember the formula. You need to just understand the concept. So we are right now in the today's lecture talking about conventional representations. In the conventional representations, we are talking about the normalization. In that, default normalization is explicit. When tomorrow we are going to have the standard representation of floating point numbers, which is IEEE representation 754. In that we will be having different scenario अलग होगा, implicit normalization होगा, explicit normalization पता नहीं होगा या नहीं होगा. We will see tomorrow. That is the tomorrow's topic, IEEE 754. But in the conventional one we have explicit normalization as the default one. ठीक है, चलिए पढ़िए, सुनिए, आपको सारी चीजें क्लियर हो जाएंगी. व्हाट इज द वैल्यू, हाउ यू गेट द वैल्यू आउट ऑफ दिस. फर्स्ट ऑफ ऑल लेट्स रिजॉल्व द साइन की प्लस है या माइनस है. टू रिजॉल्व द साइन आई एम राइटिंग लाइक दिस -1 to the power s. कैसे करेगा? इफ साइन बिट इज 0 मींस प्लस, you remember, right? Positive. So what you need to do? -1 to the power 0. Something to the power 0 is 1. Yes, so this -1 to the power s becomes +1. If suppose s is 1, answer should be negative. Yes, -1 to the power 1, which means this number becomes negative. Sign is sorted. Yes, into multiply so that it can have a positive negative sign. Now suppose right now I am talking about explicit normalization. मैं बात कर रहा हूं explicit normalization की. So in the explicit normalization, how do you get the mantissa? Mantissa is the number after the point. Before the point क्या है? 0. So what you get is 0 point और point के बाद क्या मिला? mantissa. अब आप बोलोगे सर कि इसमें तो नंबर में पॉइंट था बट mantissa में नहीं लिया. जी हाँ, वी डोंट स्टोर दिस पॉइंट, वी डोंट स्टोर बिफोर द पॉइंट व्हाटएवर द बिट्स वी हैव दोस. हम वो मेमोरी में स्टोर ही नहीं करते हैं. हम क्या स्टोर करते हैं? आफ्टर द पॉइंट नंबर्स ओनली. आफ्टर द पॉइंट नंबर्स ओनली. We store only what? After the point number. So after the point whatever we have that we store. अगर हमें recover करना है number, so I can write down 0 point and mantissa whichever I have stored here into 2 to the power original exponent. यही था ना number. Original number was this only, that 2 to the power original exponent. But do we store small e original exponent here? No, we store what? Capital E we store, and that is small e original exponent plus bias करके store किया था. So if I want to get the original exponent back, what should I do? आप ही जल्दी से टाइप करके बताओ. How can I get original exponent? By subtracting bias from this capital E. So I'll be writing capital E minus bias. अब रटना नहीं है सर मैडम, बिल्कुल रटना नहीं है. Don't remember or try to remember the formula. Try to understand the concept which I am telling you since my first class. समझो समझो समझो. समझोगे तो ज्यादा दिन तक याद रखोगे. If you learn, you can remember the concepts for longer time. You can remember anything for longer time. Otherwise आगे पाठ पीछे सपाट कल फिर भूल जाओगे. Now, this is the formula for explicit normalization. Let's try to write down the formula for implicit normalization. What will be the formula? Sign is as it is. Fine. In the implicit normalization, what mantissa you store? After the point. But before the point, what you have? 1 point n into 2 to the power original exponent. How do you get it? E minus bias. That is the value formula for implicit normalization. I guess you will be able to understand this much. इतना तो आपको सबको समझ में आ गया होगा. All the members who are learning here live, and if you are liking the lectures, like the video so that maximum students can be reachable from our end. हम कोशिश करते हैं आप लोग को अच्छा कंटेंट देने की. We are trying to give you good content. Try to make us reachable for maximum number of students so that maximum students can be benefited out of these lectures. Okay, so if you are fine with this normalized mantissa, biased exponent and this value formula, then let's have a practical example. एक क्वेश्चन करके देखते हैं and then we will try to understand slowly all the things. चलिए, so let's see this question. I will solve, don't worry, आपको कुछ नहीं करना है, just learn how to solve such questions. Fine, look at this. Consider a 16-bit register used to store floating point numbers. So we have a register of how many bits? कितने bit का register? 16 bit का register. Here is the 16-bit register. Fine. Now, what should we do in that? We have three fields. We know that S, E, and M. Fine. S, how many bits for sign? हमेशा 1 bit. How many bits for exponent mantissa? I don't know. The mantissa is normalized signed fraction. Only given that the normalized, but not given that which type of normalization. If not given which type of normalization, then which is the default one? Explicit normalization. So I will say by default explicit normalized. Fine. Exponent is represented in XS32 form. Just few minutes back I explained you, थोड़ी देर पहले ही तो बताया आपको कि XS32 form means bias value is given is equal to 32. Bias value given is 32. So I am writing this XS32, which means bias value is 32. And we know कि bias value is 32 means number of bits required to represent bias is what? K bits. So bias is 2 power k minus 1 is equal to 32. 2 power k minus 1 equals to 2 power 5 means k minus 1 equals to 5. K की वैल्यू हो जाएगी 6. अब ये कैलकुलेशन मुझे लगता है आपको समझ में आएगा. 6 bits for exponent. Total 16 bits for entire number. Then how many bits for mantissa? 16 minus 7, 9 bits for mantissa. Simple. ठीक है, आगे बढ़ते हैं. What is the 16-bit value of this number plus 13.5 of decimal? Fine. 16-bit value will be what? Okay, so for sign, it's a positive number. Yes, positive number means the sign will be equal to 0. So ये sign तो हमने ले ली 0. Now, just convert this number into binary. कैसे लिखेंगे binary में? 13 is 1101.5 is 0.1. अब ये conversion you need to learn यार. In the regular number system you can learn this easily. This is the binary. Now this particular number we have in the binary, I have taken only inside value. Why? Just because plus I have already represented by sign 0. Now this number I'll have to normalized. Which normalization? Explicit normalization, boss. Explicit normalization. Why? Just because it's default one. It is the default one. The default one is explicit normalization, right? तो default one explicit normalization करो, explicit normalize इसको. How much it will be? 0 point में convert करेंगे 1101 into how many times you are shifting the dot here? 1, 2, 3 and 4 position, 2 power 4. It will be 2 power 4. Great, Aman. Super. This is the explicitly normalized number. Now from here, can I get mantissa? Yes. क्या मिलेगा? 1101. Fine. What is the original exponent? 4. Can I store original exponent ऐसे ही? No. As it is no, then I will store capital E, which is 4 plus bias value 32, which is 36. So 36 in the binary I will be storing here. So what will be the 36 in binary? What will be 36 in binary in 6 bits? So 32, 16, 8, 4, 2, 1. So store 6-bit exponent is 100, 100. 9-bit Mantissa. Now we are having Mantissa only of 4 bits here. Only of how many bits? 4 bits here. If we have only 4 bits here in Mantissa, I'll have to store the Mantissa in 9 bits. क्या करेंगे? 0 add कर देंगे. We will add extra 0. Hello, hello, hello. So we will add extra 0. How we will write it? Like this way. 1, 1, 0, 1 and remaining 5 bits. अब आपको आएंगे चक्कर, सर ये इधर क्यों 0 ऐड किया? अरे भाई ये तो देखो कि मेंटिसा नंबर कौन सा है. मेंटिसा इज द नंबर आफ्टर द पॉइंट. इट इज हियर आफ्टर द पॉइंट. सो इफ यू आर हैविंग द वैल्यू आफ्टर द पॉइंट, you will have to add zeros in the right side. कैसे? अरे सिंपल सी बात है बाबू. 0.3 और 0.30 सेम टू सेम होना मांगता. सेम टू सेम है कि नहीं है? हाँ है. बट इफ आई एम सेइंग 0.3 एंड 0.03, अब बताओ कौन सा सेम टू सेम है? दीज आर टू सेम टू सेम? नो, दिस इज सेम टू सेम. So mantissa is after the point number. That's why padding we will do in the right side. ये अब रटना नहीं है, समझो. You have basic knowledge of mathematics. You all are math student. तो इतना तो समझ जाओगे. Got it? Got it? Got it? Got it? Got it? Got it? Okay, okay, okay. Fine. Now, if you got it, then this is my answer. This is my answer. This is 16-bit answer. So I am writing answer once again here. Answer is 0. Then 100, 100, then 1101, 1, 2, 3, 4, 5. This is the 16-bit number which they asked. I have given. Did you understand this much? आपको इतना क्लियर है क्या? जल्दी से टाइप करके बताओ in the comment box so that we can go further. Are you clear about this much or not? If you are clear, then we will go further. आगे बढ़ेंगे. अगर clear है तो type down in the comment box if you are clear. Let's see another question. Okay, question is 4-digit hexadecimal value for same 13.5. अभी देखो, मोस्ट ऑफ द क्वेश्चन विल बी आस्क्ड व्हाट. ऐसा नहीं पूछेंगे. फाइनल रिजल्ट दे विल नॉट आस्क इन बाइनरी, दे विल आस्क कि इसको हेक्सा में कन्वर्ट कर दो. 16-bit बाइनरी you can convert in the 4-digit hexa. Yes, 1-digit hexadecimal is equal to 4-bit का बाइनरी आपको पता है. Yes, so convert this. So answer we are having is 0, 100, 100, then 1101 and then 1, 2, 3, 4, 5. This is the binary number. Convert this into hexadecimal. How do you convert? 4 bits का combination ले लेना boss. 0, 1, 0, 1, 0, 1, 0, 1, 0 is how much? 10. A. Then 1, 0, 0, 1, 9. And here 0, 1, 00, which is 4. 4, 9, A, 0 of hexadecimal answer. सिंपल, वेरी वेरी सिंपल. बहुत आसान है यार, बहुत आसान है, बहुत ही आसान है. गॉट इट? चलिए अब ये है क्वेश्चन आपके लिए. व्हाट इज द मैक्सिमम वैल्यू विच इज रिप्रेजेंटेड इन दिस रजिस्टर? क्या मैक्सिमम वैल्यू रिप्रेजेंटेड है इस द रजिस्टर में? Okay, so if you want to go for maximum value in this register, you need to understand what values you are storing. आपको समझना होगा what values you are storing. You are storing sign, you are storing exponent, then mantissa. If you want to store maximum value, of course positive value. So for maximum value, number should be positive. Yes. Exponent all ones ले लो. 1, 2, 3, 4, 5, 6. 6-bit exponent, 1-bit sign. Mantissa I can take what? Of 9 bits, Mantissa I can take as all ones. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the combination for maximum value. अब ये मैंने कैसे निकाला? अरे कोई रट के थोड़ी आया. कंसेप्ट है मैक्सिमम वैल्यू, मतलब सबको मैक्सिमम ले लो. कोशिश किया मैंने मैक्सिमम लेने की. आई डिड इट. गॉट इट? समझ में आया कि नहीं आया? आ जाएगा. Now, if this is the exponent 6 bit ka and this is the mantissa of 9 bits, what will be the value? Value kya hogi iski? What is the value represented by this? Value, you know how to use the value formula. This one I am telling you now. Which exponent? Which normalization? Explicit normalization. So sign is plus, of course, minus 1 to the power 0. I can write directly here. Minus 1 to the power 0 into mantissa, 0 point all mantissas 1 2 3 4 5 6 7 8 9 into 2 power 6 bit exponent maximum value कितना आएगा 63 minus 22. Now let's calculate this how much it is. एक काम करते हैं, this is the plus of course. This point I am shifting here. So 9 bits these are, right? 9 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9.0 into this point I have shifted here a smaller value I have made larger. So I'll be writing 2 power minus 9 into 2 power 63 minus 32, 31. Is that much clear? चलिए उसको और थोड़ा सॉर्ट करते हैं. Plus value, this 9 ones is nothing but 2 power 9 minus 1. Right? Into 2 power. How much this one? How much this one? 2 power 31 into 2 power minus 9. It becomes 2 power 22. कैसे किया? 31 minus 9 कर दो. Right? This I am making 2 power 9 minus 1 is 511. It is almost equal to 2 power 9. So my answer will be 2 power 31. Almost equal to 2 power 31. That is the maximum value. That is the maximum value. That is the maximum value which you can represent. Almost equal to this. Clear है सब लोगों को क्या? Clear है सब लोगों को? If you are clear, this is the maximum value which you can represent with 16 bit, which is of course way larger than the this one. See, 16 bit से maximum value यहाँ 2 power 15 ही आ रही थी, and this is very large, larger than that. Yes, of course, a very large value you can represent. Fine. चलिए, minimum value क्या होगी? What is the minimum value? Minimum value will be minus का 2 power 31. ये प्लस का वैल्यू है. मिनिमम वैल्यू, इफ somebody will ask me, I'll do what? इसको माइनस करके और सेम चीज I can represent. So what is the minimum possible value which you can represent is this minus का 2 power 31. Simple. How? अरे from previous question. नहीं समझ में आया? अरे यार, प्लस का जो मैक्सिमम है उसको माइनस कर दोगे तो वो सबसे मिनिमम नहीं बनेगा क्या? I guess you could understand. What is the smallest possible positive value represented in this register? बहुत सारी छोटी छोटी चीजें सिखा रहा हूं, देखो आपको ये बहुत बहुत डिटेल की चीजें बता देगी. What is the smallest possible value which you can represent? तो सबको छोटा छोटा ले लो. Everything you take small minimum value. So S, of course you need to take positive value, then exponent, then mantissa. What minimum value of exponent you can store is all zeros. 1 2 3 4 5 6. What minimum value of mantissa you can store? अगर आप बोलते हो all zeros, आप गलत हो. You cannot store all zeros. Why? Just because if you go for the explicit normalization, मैंने बताया था, in the explicit normalization 0.1, after the point you should have a single bit 1 here. Yes, needed, of course needed. So minimum mantissa value you can have is after the point first bit 1, remaining all zeros. This is the minimum possible mantissa you can have. आप इससे छोटा नहीं ले सकते. इससे छोटा नहीं ले सकते. Why? Just because here after the point a single bit 1 should be required. Okay, if you are fine with this, इसकी value निकाल लेते हैं. Value will be what? This is positive, yes. Then mantissa is what? 0.1 into 2 power, this is 0 minus 32. So this becomes 0.1 into 2 power minus 32. 0.1 is nothing but 1 by 2. 1 by 2. So you can have is 2 power minus 33. That is the smallest value, positive value, which you can represent in this register. इससे छोटी वैल्यू हुई तो यू कैन नॉट स्टोर स्मॉलर देन दिस. अभी देखो एक छोटी सी चीज बताता हूं. यूजिंग दिस पर्टिकुलर एग्जांपल ओनली आई हैव गिवन दैट वी हैव अ पॉजिटिव मैक्सिमम वैल्यू, right? And then we have a negative minimum value, then we have a positive minimum value also here, then we have a negative maximum value also. Maximum value मतलब इधर बढ़ेंगे तो बढ़ेगी ना. Yes, here is the zero. You know what happens in the conventional representation? These you cannot store. Lesser than this, look at this, lesser than this you cannot store. एंड सिमिलरली पॉजिटिव नेगेटिव दोनों में अराउंड जीरो, इससे छोटा इधर से बड़ा यू कैन नॉट स्टोर, एंड दैट इज कॉल्ड एज अंडरफ्लो. अंदर की वैल्यूज यू कैन नॉट स्टोर. Similarly, if that was the maximum value 2 power 31, after 2 power 31 these values are overflow values which you cannot store, and similarly below this these are also overflow which you cannot store. लिमिटेशन, कुछ तो लिमिटेशन होगी ना. So remember, in the floating point representation we have some underflow around 0 and we have some overflow after the maximum possible values. Now another question, and that particular question says that this number minus 25.75 you need to represent in the same type of register, same XS32 code, menticized, normalized. Not given normalization means I will have to use what? I'll have to use the explicit normalization only. Quickly कर ले, बहुत जल्दी हो जाएगा. Yes, quickly you also solve, I will also solve. Practice question है, जल्दी से solve करते हैं. Let's solve it quickly. So same to same question, sign is of 1 bit and then exponent of how many bits? Exponent of 6 bits. How? This x is 32 form, and then menticize 9 bits, same to same question. Minus 25.75. For minus, can I keep a 1 here in sign? Yes, fine. Okay, this is of decimal. Let's convert 25. 25 is 16 plus 8, 24, then 4, 2 and 1. 16 plus 8, 24 plus 1. This is 25 plus 7.75 is 1, 1, and that is of binary. Now, what normalization? Explicit normalization. क्यों किया? Not given in the question, then it is the default. एक्सप्लिसिट नॉर्मलाइजेशन कर दो भैया. एक्सप्लिसिट नॉर्मलाइजेशन अगर करेंगे क्या मिलेगा? 0.11001111 इंटू 2 पावर कितना? 1 2 3 4 5. 0.001. नो 0.001 नहीं आएगा. 0.11. 0.75 is 0.11. 3 by 4. 3 by 4. 3 by 4. Okay, so this is the normalized answer. Now from here can we get Mantissa? Yes, Mantissa मिल गया 1100 and 3 bar 0. And what is the original exponent? 5. Can we get capital E? 5 plus 32 which is 37. चलिए स्टोर करते हैं इसको. 37 which is 36 plus 1, so 32, 4, 36 and 1. This is 37. Mantissa is 1100 3 times 1. This is 7 bits. You can have 2 more bits extra. Clear? Okay, no problem. एक बार देख लीजिए. If you are clear about this or not, you can have multiple different values and you can practice such kind of so many questions. आप लोग अलग अलग values लेके और practice कर सकते हो such kind of questions. यू कैन वेरीफाई विद ईच अदर। आपके पास बहुत सारे अच्छे दोस्त होंगे जो आपके साथ प्रिपरेशन कर रहे हैं। यू जस्ट टेक द सेम क्वेश्चन एंड ट्राई टू मैच द आंसर्स। चलिए, सो दिस इज अ गेट क्वेश्चन वी हैव फॉर यू। दिस इज very special question, but before we solve the question, I want to give you few specific points to remember. What are the points to remember? Look at this. First thing, if more number of bits are used, see, I am writing these points for you. मैं बोल के भी खत्म कर सकता था, but I am giving you all these points for you so that you can have some notes. And how you can get all those notes if you are not aware of it, I will tell you. Look at this. कहाँ गया ये रहा. This Unacademy Gate CS is the Telegram channel. If you haven't subscribed it, go and follow that. After the class, I will drop my PDF here, so you will be able to download this PDF of the annotated classroom lecture, and all the previous lectures का notes are present here. तो आप लोग यहाँ जाएंगे, then you will be able to. फाइन, ओके फाइन, ओके। चलिए वापस आते हैं, इस क्वेश्चन को सॉल्व करते हैं। व्हाट दिस पर्टिकुलर क्वेश्चन सेज, आई वाज टॉकिंग अबाउट पॉइंट्स टू रिमेंबर। इफ मोर नंबर ऑफ बिट्स आर यूज्ड फॉर मेंटिसा, अगर हम ज्यादा बिट्स यूज करेंगे मेंटिसा में, विच मीन्स व्हाट, वी कैन हैव मोर प्रिसीजन in the number. We can have more precision, or I can say we can have more accuracy in the number. More accurate number I can have. कैसे प्रूव कर लेता हूं? If I am giving you 0.11, instead of that, if I am giving you 0.1101, you only tell me which particular number is more accurate. Second one. Why? After the point, it is giving me more bits. समझ पा रहे हो? So if I can store more number of bits in Mantissa, then I can store more precise number. If I cannot store more bits in Mantissa, I might have lost some bits because of that. कुछ bits lose कर सकते हैं. So more number of bits in Mantissa means more precision, more accuracy. Second one, if more number of bits are used for exponent. For what? Exponent. Then what happens? अगर exponent में आपने ज्यादा bits ली है ना, तो आपको क्या मिलेगा? You will be getting a larger range of the numbers. If you want to store the numbers in the larger range, ज्यादा range में चाहिए, you use the more number of bits in exponent. If you want more accuracy, you use more bits in Mantissa. Remember the point. Okay, remember the point. So there is a particular query that before question you did not cover 0.1. Which 0.1 I did not cover? 0.1 value. Okay, if you want to have 0.1 value, just because if you want to have a 0.1 value of normal decimal number system or a decimal system or maybe in a regular number system, you can do it. आप एक काम कीजिए, if there is no any, okay, I'll tell you one thing like this. If the number is this, 0.1 you want to store of binary. How can you store? Arey, you can do this na, 0.1 of binary into 2 power 0. That is the number. Yes. So what is the original exponent I am getting? 0. So you can store capital E is equal to 0 plus 32 or 0 plus bias. कर लो ऐसे and go for it. It's very simple. कोई confusion नहीं है. If there is no any exponent you are getting, then what you can go for it is 2 power 0. Original exponent 0, stored exponent plus bias. Simple. चलिए question solve करते हैं. Let's solve the question. So question is, data given below is this. Okay, exponent is x is 64. 64 is 2 power 6. ओके, सो व्हाट विल बी द नंबर ऑफ बिट्स हियर यूज्ड फॉर दिस इज 7. कैसे लिख दिया, मुझे पता है 2 पावर k minus 1 is equal to 64, which is 2 power k minus 1 is equal to 2 power 6, k की value 7. So 7 bits are used for exponent, and in the question it's not given, but I should give you that 16 bits are used totally here from here to here. Sign bit 1, 7 bits are exponent. How many bits for Mantissa? 8. Mantissa is a pure fraction in sign magnitude. Pure fraction मतलब आपको नॉर्मलाइज नहीं करना है, आपको नॉर्मलाइज नहीं करना है. नाउ व्हाट टू डू, द डेसिमल नंबर 0.0239 into 2 power 13 has following hexadecimal representation without normalization and rounding off. अभी देखो 0.239 into 2 power 13, you don't have to multiply this number. No, don't multiply it, take it or consider it in your एक्सपोनेंट. एक्सपोनेंट में कंसिडर कर लेना, आप मल्टीप्लाई नहीं करो. सो व्हाट यू नीड टू डू इज दिस 0.239 into 2 power 13 you will have to write into 0. whatever into 2 power 39 and 2 power 13, and this particular whatever I'll have to convert into binary. 2 power 0.239 को you need to write in the binary. और कितनी बिट का बाइनरी? only 8. क्यों? जस्ट बिकॉज मेंटिसा इज ऑफ 8 बिट्स, इसलिए मैक्सिमम 8 बिट्स तक लेके जाओ. सो यू नीड टू कन्वर्ट दिस 0.239 इनटू बाइनरी. करके देखो कितना आता है. डू इट. हाँ, मैं आपसे पूछ रहा हूं, करके देखो भाई. सो व्हेन यू विल डू इट, आई गेस इट शुड बी लाइक दिस वे, 001111101. 8 बिट्स, दिस मच यू विल बी गेटिंग. कैसे करते हैं आपको पता है क्या? 0.239 into 2. After that you will be getting before the point whatever. If it is 0, then take it 0 here. If it is 1, take it 1. If it is 1, remove 1, and after the point whatever value you have into 2 again and go on. ये मेथड सीखी थी आपने? हाँ हाँ हाँ, फर्स्ट ईयर में कोई तो सीखी थी, याद थोड़ी रहती है सर, याद रखना चाहिए ना सर. This is the number. Now they clearly mentioned कि आपको without normalization store करना. Without normalization you need to store. So what you need to do is, this is only the mantissa to store 0 0 1 1 1 1 and 0 1. Original exponent you are getting is 13. So capital E will be what? 13 plus exponent 64. Sorry, by 64 it is 77. चलिए, so let's store this value in your register. Let us store it. Let us store it. Now, what is this? Sign, exponent, mantissa. What is the sign? It's a positive number or negative number? Positive number 1. Exponent is 77 in 7-bit binary. 7-bit binary में 77. So 64 and then 13, right? 13 means 4 bits. 13 is 1 1 0 1. And mantissa is how much? 0 0. 4 times 1 and 0. Let's convert this into hexadecimal 4 digit. So it will be 1101, which is 9. Or 1101 is 9. No. 1101 is 13. 13 is D. Then we have 00113. Then 1101 again D. And then 11. Okay, sorry. One mistake I have done. Positive it is. So positive के लिए sign यहाँ आएगा. ओहो. Sign will be 0, not 1. Sign is 0. So it will be 0110, which is 4. 4D, 3D. 4D, 3D. Good, Vivek. Nice. 4D, 3D. Next. Agla question. Question number 2. Same thing, but what they have given is normalized presentation of above format is specified as follows. तो इसको normalize करना है. The mantissa has an implicit preceding. Implicit preceding means implicit normalization करना है. Assume that only zeros are padded in while shifting the field. मतलब अब ये जो मेंटिसा मुझे मिला था, अब यहाँ से इसको if you will be normalizing it, if you are shifting it, then only zero will be padded at the end. Then what they say, normalized representation of this number, same number is what? Okay, let's do that. So we will be having 0.239 into 2 power 13, which was 0.00111101 into 2 power 13. Now I am going to go for implicit normalization. कर दीजिए implicit normalization. When you go for implicit normalization, it will be equal to how much? 1 point something, 1 point 1 2 3 0 1 and 3 times 0 into 2 power this smaller number I am shifting towards larger number. I have to multiply by 2 power minus 3 into 2 power 13. So it becomes 1.11101 3 times 0 into 2 power 10. From here, can we get mantissa? Yes, which is 1, 2, 3, 4, 5, 6, 7, 8 and original exponent is 10. So what will be the capital E? Capital E will be 10 plus bias 64, 74. Let's try to store this in our register. Let's try to store. अरे line चाहिए line. फाइन, चलिए देखते हैं. Sine, exponent and mantissa. Sine is plus only 0, exponent is 74, so it is 64 plus 10, 1010. Mantissa is 11101 and 3 times 0. So what it will be in the hexadecimal? It is 8. 1110. This is E. 1010 is 10, which is A, and 0100 is 4. 4AE8. 4AE8 answer is D. तो इस तरीके से आप क्वेश्चन को समझिए एंड देन यू कैन सॉल्व इट इजीली. फाइन, चलिए कुछ और क्वेश्चंस हैं बट हम वो कल देखेंगे. व्हाई? जस्ट बिकॉज वी आर हैविंग सो मेनी डिसएडवांटेजेस ऑफ दिस कन्वेंशनल रिप्रेजेंटेशन. Till now, whatever I explained is not the standard. It's a conventional representation which was given initially. It has lots of problems and those problems were taken, were overcome, were solved in the standard one, which is IEEE 754 format. So what are the disadvantages? The first disadvantage is it can not store zero. इसमें आप zero store नहीं कर सकते. क्यों? अगर आपको इफ यू वांट एक्सप्लिसिट नॉर्मलाइजेशन का रूल पता है, 0 पॉइंट और यहां पे आना चाहिए 1. इफ यू हैव अ 1 बिट 1 हियर देन 0 तो हुआ नहीं. इम्प्लिसिट नॉर्मलाइजेशन में बिफोर द पॉइंट व्हाट शुड यू हैव अ बिट 1. तो सेम टू सेम थिंग, इफ यू आर हैविंग अ 1 इन द नंबर देन हाउ कैन यू रिप्रेजेंट 0? यू कैन नॉट. So that floating point representation which is conventional one, it cannot represent 0. इसमें 0 होता ही नहीं है. Second thing, it cannot represent infinity. यहाँ पे infinity को represent नहीं कर सकते अगर चाहिए तो. All these will be there in our standard one. Similarly, it can not store or represent a number which is not normalized. अगर कोई नंबर को हम नॉर्मलाइज नहीं कर सकते, if there is a number which cannot be normalized, then that number cannot be stored in the conventional representation. If you will do it, then might possible either you will lose the number, either you will lose the some kind of accuracy, or you can say it's not representable. In the floating point representation, which is a standard one, IEEE one, which we are going to see tomorrow, that can have this. उसमें आपको मिल जाएगा, कैसे मिलेगा वो हम देखेंगे कल. So tomorrow's session we are having 5:30 p.m. for what? Standard one IEEE 754 format. उसमें हम देखेंगे हाउ एग्जैक्टली यू आर गोइंग टू रिप्रेजेंट द जीरो इन्फिनिटी डीनॉर्मलाइज नंबर एंड ऑल. बहुत कुछ डिटेल में मिलेगा आपको सीखने को. यू विल लर्न अ लॉट. टुमारो वी विल मीट फॉर दिस वन. इफ यू आर फॉलोइंग माय PYQ सेशन ऑन YouTube, tomorrow 9 a.m. I am going to bring lots of questions from instruction chapter. Yes, from instruction chapter I am going to solve the problems of instruction and addressing modes. Tomorrow PYQ 9 a.m. we are going to solve lots of questions of instructions and addressing modes. Apart from that, you can see CN is going on our gate schedule 11 a.m. Malesham sir taking TOC 4:30 p.m. My class is going on. Tomorrow is the last class of the topic. पूरा subject cover हो जाएगा कल. And then this Satish Yadav sir discrete math 8:30 p.m. So this is the gate schedule you need to follow. अगर आप लोग को Unacademy सब्सक्रिप्शन लेना है प्लस का, आज ही लें. Why? Just because today is the last date. Before that you can have your subscription prices less. Otherwise tomorrow onwards it will be increased. कल से बढ़ जाएंगे prices. Yes, use the code VDEEP10, get the discount and get your iconic subscription or plus subscription with the discount 10% का discount. प्लस यू कैन यूज द नो कॉस्ट EMI ऑल्सो. हाँ जी, आप पैसे इंस्टॉलमेंट में दें और कोई एक्स्ट्रा पैसा भी नहीं लगेगा. कैसे? इफ यू हैव योर एनी क्रेडिट कार्ड और HDFC का डेबिट कार्ड, देन यू कैन गो फॉर नो कॉस्ट EMI. अगर आपको एक साल का सब्सक्रिप्शन लेना है, after the discount it will be 22,500, but that same amount you can pay in the installment of 3 months, 6 months, 9 months, 12 months, और आपको एक्स्ट्रा 1 रुपया भी नहीं देना है. You don't have to pay a single penny extra apart from this exactly 22,500. And this is our Facebook connection with you. So go to this Gate Aspirant channel on the Facebook and be connected with us so that you can hear from us a lot more announcements and multiple things. This is the members group of Gate Aspirants for ECI and electrical, and this is the channel I already told you to join for all the live PDFs. दिस इज द फैमिली. यहाँ पे हम पढ़ाते हैं आपको अनलिमिटेड लर्निंग, आपको देते हैं क्वालिटी लर्निंग वी प्रोवाइड. सी दिस इज फॉर इलेक्ट्रिकल ECI and creatrix page of YouTube. Recommend your friends to go with this particular page. You will be learning a lot, your friends will be learning a lot. For mechanical we have Unacademy Gate ME, Unacademy Gate CE. For civil, for Telugu language we have a separate channel. So language specific people also don't have any barrier, आपको Telugu language में भी पढ़ने को मिलेगा. Then SSC JE computer science current one. If you haven't subscribed, subscribe the channel. घंटी भी बजा दो ताकि जब भी मैं क्लास लेने आऊँ आपके फोन की घंटी बजेगी. Then foundation engineering, engineering pathshala, electrical junction. There are so many channels over which we are providing free education, quality education to you guys. Utilize these for your knowledge, utilize these for your career, for betterment of your knowledge, betterment of your understanding. Okay, so here I am logging off for the day. We will meet soon again tomorrow 9 a.m. for PYQ session, then 5:30 p.m. for floating point representation. Till then, happy learning, keep learning, enjoy the day, rest of the day. Thank